in the construction of LL1 parsing table for the following grammar, m of s comma, this is left parenthesis, and m of w comma dollar. That means we have to find the entries in row s column left parenthesis and in row w column dollar. Here LL1 parsing table is constructed like this. In rows are named as the non-terminals in the which are present in the grammar. Here the non-terminals are starting symbol S, X, Y and W, and the terminals and the columns are named as terminals. Here terminals are left parenthesis, right parenthesis, plus star and star int and dollar. So these are the non-terminals present in the terminals present in the grammar. Here we have to find the entries in row S and column left parenthesis, in row W and column. So that means this entry and this entry we have to find. So while constructing LL1 parsing table, add LL1 parsing table construction algorithm is add A gives alpha to m of A comma A for each terminal A in first of alpha. If first of alpha contains epsilon, then add A gives alpha to m of A comma B for each terminal B in follow of A. This is a algorithm for constructing LL1 parsing table. Here we have to find entry S, entry in row S, column left parenthesis. That means the production should start with S. The production should start with S, and the first of left hand side should be this left parenthesis. So like that we have to check for the productions. Those productions will be coming into this entry. So if we see S gives XY, here first of XY is first of X. First of X is, so this one, left parenthesis. So we can say that this entry is nothing but S gives XY. So first one is X gives XY. Now we have to find M of W comma dollar. W comma dollar. So this entry. This production should start with W. W and whose first of whose right hand side, the right hand side of that production should consist of dollar. First of that production, for example, if you take this one, this production, first of this is if we see this production W, first of this is star, so first of this in the entry here the production will be W gives star X. We want this entry. So now let us consider W gives epsilon. Here first of epsilon is epsilon. So we have to find fall of W and the symbols which comes under fall of W, these productions will be coming below those terminals. So now let us find W of fall of W. If we find fall of W is first of fall of X. Fall of X is nothing but first of Y. First of Y is plus. So under Y this symbol will be coming under plus. So W gives epsilon. This production will be coming here. And first of Y is also epsilon. So first of fall of X is nothing but fall of S. And fall of S, as S is the starting symbol, fall of S contains dollar. So fall of X is nothing but fall of W. That means W under in row W and column dollar, fall of S is fall of S is sorry, fall of W contains symbol dollar. So this production will be coming here. So your correct option is S gives XY and W gives epsilon. So option C is the correct option.
ARQ, the system has set the timeout value which is equal to the half of the time required to receive an acknowledgement. When the station A sends n frames to station B and no errors occur during transmission, how many duplicate frames the receiver B will discard? So it is for example, there are two stations, station A and B. Normally the timeout value of the sender will be equal to the round trip time. Okay, but here which is set equal to the half of the time required for acknowledgement. Normally when station A sends a frame, it has to wait till the acknowledgement is arrived. For a frame 0, ACK 1 will come. So it will within the time, for example, it 10 milliseconds is the timeout value. Within 10 milliseconds, if the packet is not acknowledgement is not arrived, frame 0 will be retransmitted. That is a normal case. But whereas if the frame is arrived correctly, that means you have to wait till the acknowledgement is arrived. That means how much time it will take to go for the frame and then coming acknowledgement, which is equal to round trip, frame transmission time and then acknowledgement transmission. Okay, so half of the time if you set means every frame will become a duplicate frame. Frame 0 will be received and it will be discarded. Again frame 1 will be sent, frame 1 will be discarded, like that. If n number of frames are sent, then n number of frames will be discarded, because without receiving acknowledgement only frame 0 will be retransmitted again, so that it will become a duplicate frame. Every frame that A transmitted will be a duplicate frame. So n is the correct answer.